Another day, another story. Chandrayaan-3 is the third lunar exploration mission undertaken by the Indian Space Research Organisation, ISRO. It is a follow-up mission to the Chandrayaan-2 mission, which aimed to place a lander and rover on the lunar surface but faced a partial failure. Here are the key details about Chandrayaan-3. Objective. Chandrayaan-3's primary objective is to land a rover on the lunar surface and conduct scientific experiments to further our understanding of the Moon. Mission components. The mission consists of an orbiter, a lander, and a rover. The orbiter will remain in orbit around the Moon, while the lander and rover will descend to the surface. Lander and rover. The lander and rover are being designed to withstand the harsh lunar environment and perform various scientific experiments, including studying the lunar soil, conducting mineralogical analyses, and studying the lunar atmosphere. Improvements from Chandrayaan-2. Chandrayaan-3 incorporates lessons learned from Chandrayaan-2 to ensure a successful landing. It will address the issues faced during the landing attempt of the previous mission. Collaboration. ISRO has sought international collaborations for Chandrayaan-3 to enhance its scientific capabilities. This may include payloads from other countries. Launch vehicle. The mission is expected to be launched using India's Geosynchronous Satellite Launch Vehicle, GSLV, Mk3, a powerful rocket capable of carrying heavy payloads. Launch date. The exact launch date of Chandrayaan-3 has not been announced yet. ISRO is currently in the development phase, and the launch will be scheduled based on the mission's readiness. Landing site. The specific landing site for Chandrayaan-3 has not been disclosed. However, it is likely to be a different site from the previous mission to explore new regions of the Moon. Scientific objectives. The mission aims to study the lunar surface, the Moon's mineralogy, water ice presence, and the lunar exosphere. It will provide valuable data for lunar science research. Technology demonstrations. Chandrayaan-3 will also include technology demonstrations to test new equipment and systems for future lunar missions. Payloads. The mission will carry a set of scientific instruments and payloads on board the lander and rover. These payloads will facilitate the study of the lunar surface and its environment. Rover mobility. The rover will be designed to traverse the lunar surface, collecting samples and performing in situ measurements to study the composition and characteristics of the Moon. Communications. The mission will utilize the Deep Space Network, DSN, for communication between the spacecraft and Earth-based ground stations. Cost. The estimated cost of the Chandrayaan-3 mission is not publicly available. However, it is expected to be within the budget allocated by the Indian government for lunar exploration. Public outreach. ISRO aims to engage the public and increase awareness about lunar exploration through various outreach activities related to Chandrayaan-3. International significance. Chandrayaan-3 contributes to the global efforts of exploring the Moon and expanding our understanding of Earth's natural satellite. It showcases India's advancements in space exploration technology. Mission duration. The duration of the Chandrayaan-3 mission will depend on various factors, including the health and performance of the spacecraft and the scientific objectives to be achieved. Lunar sample return. Unlike the upcoming Chandrayaan-3 mission, there are currently no plans for an Indian lunar sample return mission. However, future missions may include sample return objectives. Data sharing. As with previous ISRO missions, data from Chandrayaan-3 is expected to be made available to the global scientific community for analysis and research purposes. Collaboration with other agencies. ISRO may collaborate with international space agencies, including NASA and ESA, to share resources and knowledge for Chandrayaan-3. Predecessor missions. Chandrayaan-1, launched in 2008, was India's first lunar mission and successfully orbited the Moon. Chandrayaan-2, launched in 2019, attempted a soft landing but faced challenges during the final phase. Public support. The Chandrayaan missions have garnered significant public support and interest in India, highlighting the country's enthusiasm for space exploration. Technological advancements. Chandrayaan-3 will build upon the technological advancements achieved during the previous missions, leading to further improvements in India's space capabilities. Data utilization. The data and scientific findings from Chandrayaan-3 will contribute to the existing knowledge about the Moon's geology, mineral resources, and potential for future lunar missions. Inspiring future generations. The success of the Chandrayaan missions inspires and motivates young minds in India to pursue careers in science, technology, engineering, and mathematics, STEM, fields. Lunar mapping. Chandrayaan-3 will contribute to the mapping of the lunar surface, helping to identify potential future landing sites and explore regions that have not been extensively studied. Moon-Mars connection. Chandrayaan-3's findings will also aid in understanding the Moon's history and its potential relationship to Mars, as both bodies share some similarities in terms of geological processes. Risk mitigation. ISRO will incorporate risk mitigation strategies based on the lessons learned from Chandrayaan-2, including refining the landing sequence and ensuring robust communication systems. Lunar resources. Chandrayaan-3's investigations into the lunar regolith and potential water ice presence will contribute to the understanding of lunar resources that could be utilized for future human missions. Lunar day and night operations. The rover onboard Chandrayaan-3 will be designed to operate during both lunar day and night, leveraging solar panels and battery systems to ensure continuous functioning. International Lunar Exploration Roadmap. Chandrayaan-3 aligns with the global roadmap for lunar exploration, contributing to the overall knowledge and understanding of Earth's nearest celestial neighbor. Publicly available data. ISRO is committed to making Chandrayaan-3 mission data accessible to researchers and scientists worldwide, facilitating collaborative analysis and maximizing scientific output. Orbital science. While the primary focus is on the lander and rover, the orbiter component of Chandrayaan-3 will continue to operate in lunar orbit, capturing valuable data and images of the lunar surface. Scientific collaboration. Chandrayaan-3 provides opportunities for Indian scientists and engineers to collaborate with their international counterparts, fostering scientific exchange and enhancing India's space research capabilities. Lunar seismology. The mission aims to deploy seismometers on the lunar surface to study moonquakes and gain insights into the Moon's geophysical properties. Future lunar missions. The knowledge gained from Chandrayaan-3 will inform the planning and design of future lunar missions, including potential manned missions to the Moon. Navigation and guidance. Chandrayaan-3 will feature advanced navigation and guidance systems to ensure precise landing and rover mobility on the lunar surface. Microgravity experiments. The mission may also include microgravity experiments to study the effects of reduced gravity on various biological and physical phenomena. Lunar volcanism. Chandrayaan-3 will contribute to the understanding of lunar volcanism and the formation of lunar lava flows, expanding our knowledge of the Moon's geologic history. Collaboration with industry. ISRO is likely. Thanks for watching.